For this problem, here we have some data that is relating commute time to a well-being score. And it seems as though if the commute time is increasing, that this well-being score is decreasing. And the question is there a linear relationship between them? So to start with, which one of these columns represents the explanatory variable and which is the response variable? And the way it looks is that this first column is your explanatory variable. It's explaining what is happening over here for the response. So we'll just choose the option that correctly reflects this. So the explanatory variable would be the commute time, and the response variable is the well-being score because, well, oh, nope, doesn't look like it's that one. It's because the commute time affects the well-being score. So I'm going to select option B. Okay. And what we are first going to do is look at a scatter plot of this information. So again, that could be done by hand, but I'm instead going to go into StatCrunch, and here's my data. There's a total of 7 data points. I want to get a scatter plot of this information. You can get that by going to Graph, choose Scatter Plot, and then here I'm going to, for my x variable, the explanatory variable, put in commute times. My y variable is going to be the score, which is the response variable. That is everything you need to look at a graph, a scatter plot of this data. Before we select our, the correct option here, yeah, it's definitely decreasing, and it looks like it's relatively linear. You could think of the best fit line going through looking something like this. So there does appear to be some linear relationship between these values, but here let me move this out of the way so we can now choose the correct option. So let's see, definitely not B or D, and it looks as though option A is going to be my best fit, so I'll choose that. All right, so second, going back to StatCrunch, we want to get the linear correlation coefficient, which is asking from this data, how linear is it? I'm expecting it to be a negative number, and I think it should be relatively close to -1. The closer to -1 you are, the more linear the data is in a decreasing sense. So what I'm going to do is go into Stat, Summary Stats, and there's its own option for getting your correlation coefficient. All you have to do is select both of these columns. So I'm going to click on commute time, my x variable, hold down Command, and click Score, so I see them both over here, and it will compute the correlation coefficient for us. And it is negative. It's very close to -1, -0.9862. As we're asked to round to 3 decimal places, that's going to be -0.986. So that was -0.986. And I'll check my answer. Okay, great. Moving on in the question, this is the final part, and it says, does a linear relation exist between commute time and well-being index score? I mean, definitely the answer is yes. I mean, this is so close to -1. In general, you have to be a little bit careful. As this number gets closer to 0, it's where's the cutoff point? What if it were -0.7? I mean, is that going to be linear enough? Fortunately, there is a table of values that are given in this problem that we can use to compare this value to a table of values. So I'm going to click this to open what are called the critical values. So open that up. The way this table works is, here we have a total of 7 entries. So I'm going to go to n is equal to 7, and the corresponding critical value is 0.754. This would be your cutoff. Really, you can put a negative in front of it if you want to think of it that way. But, had this value been an absolute value less than 0.754, like maybe -0.6, then the answer would have been like, okay, no, we are below the critical value, and we can't accept that this data is linear. However, the absolute value of this is greater than this number, meaning that it is linear. So it did not drop below this acceptable rate, and that's what is meant by this critical value. I'll close that, and I'm going to choose the option that best reflects this. So yes, the answer's got to be yes, that those appear to be a linear association. Of course, it's going to be a negative one, not a positive one. And it goes on to say for choice B, because R is negative and less than the negative of the critical value. That is for sure true, so I'll check my answer. And that is it.